Hello students, today we are going to discuss characteristics of function graphs. Identifying attributes of a function from its graph. You can identify several attributes of a function by analyzing its graph. For instance, for the graph shown, you can see that the function's domain is x such that 0 is less than or equal to x, which is less than or equal to 11, and its range is y such that -1 is less than or equal to y, which is less than or equal to 1. Use the graph to explore the function's other attributes. Part A says the values of a function on the interval from 1 to 3 are positive or negative. So if we go to the graph, when the x values go from 1 to 3, is my function positive or negative? I can tell here my function is going to be positive because it is above the x-axis. Part B says the values of the function on the interval from 8 to 9 are positive or negative. And the values from the function from 8 to 9 is below the x-axis, so those are going to be negative values. A function is increasing on an interval if f of x1 is less than f of x2 when x1 is less than x2 for any x values x1 and x2 from the interval. The graph of a function that is increasing on an interval rises left to right on that interval. Similarly, a function is decreasing on the interval if f of x1 is greater than f of x2 when x1 is less than x2 for any x values x1 and x2 from the interval. The graph of a function that is decreasing on the interval falls from left to right on that interval. Part C says the given function is increasing or decreasing on the interval from 2 to 4. So if we look at the interval from 2 to 4, is that function increasing or decreasing? And because it's going from high to low, that is going to be decreasing on the interval between 2 and 4. Part D says the given function is increasing or decreasing on the interval from 4 to 6. So if we look from 4 to 6, the function is going from low to high, so that is going to be increasing. For the 2 points x, f of x1, and x2, f of x2 on the graph of a function, the average rate of change of the function is the ratio of the change in the function values x2 minus x1 to the change of x values x2 minus x1. For a linear function, the rate of change is constant and represents the slope on the function's graph. Part E says, what is the given function's average rate of change on the interval from 0 to 2? So if we look from 0 to 2, it's asking what is the average rate of change. So we're going to do rise over run. So from 0 to 2, we're going to be rising 1, 2, and running 1. So we're going to rise 2, run 1. Rise 2, run 1. So my rise is 2 over my run. So my average rate of change here is going to be 2. A function may change from increasing to decreasing or from decreasing to increasing at turning points. The value of f of x at a point where a function changes from increasing to decreasing is a maximum value. A maximum value occurs at a point that appears higher than all nearby points on the graph of the function. Similarly, the value of f of x at a point where a function changes from decreasing to increasing is a minimum value. A minimum value occurs at a point that appears lower than all nearby points on the graph of the function. Part F says, at how many points does the given function change from increasing to decreasing? So we go from increasing to decreasing right here. We go from increasing to decreasing here, and increasing to decreasing here. So that's going to be 3 points. Part G says, what is the function's maximum value at those points? And if we look here, the maximum value is 1. The next part says, at how many points does a function change from decreasing to increasing? So, decreasing to increasing, so it's decreasing to increasing here. It's decreasing to increasing here, so that's going to be 2 values. And what is the function's minimum value at those points? And that would be -1. A zero of a function is a value of x for which f of x equals 0. On a graph of the function, the zeros are the x-intercepts. How many x-intercepts does this function have? We have 1, 2, 3, 4, 5, 6 x-intercepts. And what are those zeros? We have 1, 3, 5, 7, 9, and 11.